Good morning, everyone. Good afternoon to some of you. We'll give a few more minutes for more people to jump on the call, and then we'll get started. Okay, so we are a minute past noon here in Ontario. So good morning and good afternoon again to everyone on the call. Welcome to this today's webinar. We do have quite a bit of content to go through, so I would urge anyone, if you have any questions during the webinar, to raise your hand or to type it into the chat. Alternatively, we'll have a question and answer period at the end of the presentation to go through any questions you might have. So today we will be presenting to all of you on radon and radon awareness in general. My name is Alexander, and I am a radon measurement and mitigation professional. I'm certified to design radon rough-in systems in new construction, and I'm also a radiation safety officer here at Pynchon. I've been working and involved in the radon industry for almost 8 years now. At Pynchon, I am the national practice leader for radon, where I oversee a team of technical experts in our radon service line from all over the country. Together, we drive quality, innovation, and workmanship. Presenting with me will be Heather Swale, and she's the operations manager for our IEQ team in BC.
Everyone, my name's Heather. I'm the operations manager, as Alex said, in our BC offices. I've also been doing radon for quite some time now. I'm a measurement and mitigation professional for almost the last decade now. I've been doing a lot of radon work. It's certainly become a passion area for me, and we're really excited to present to you all today. So thanks for joining us.
Excellent. So before we dive too deep into the presentation, we wanted to highlight that November is Radon Action Month. So this is a national campaign held every November to raise awareness about radon gas. This is largely a collaboration between Health Canada, Karst, and Take Action on Radon. And this campaign encourages Canadians to test their homes for radon and to take action to reduce high levels. This is done through education, sharing of knowledge with others to promote community awareness about radon. So we thought it'd be important to start the presentation by sharing some information about some of the initiatives that are going on across the country and the things that you might see in your community, including the 100 Test Kit Challenge. This is led by Take Action on Radon. This program is launching now for the 7th year, where particular municipalities across Canada are selected and residents from those communities are provided free test kits to test their homes. This year, there's approximately 25 communities on that list it's showing. Some of them might be in your regions, and some of them I've noticed still have pre-registrations open. So it might not be too late if you do live in some of those regions to register for a free test kit. Also was the Made in Manitoba Radon Action Plan Symposium that happened just a few weeks ago. This was a radon action plan for the province of Manitoba that was launched and presented to the public, which highlighted a plan to drive testing in schools, daycares, and other areas, as well as education, public funding, policies, and such. Cities as well all over Canada are taking part this year, lighting up some of their signature landmarks, the color purple, on November 27th. So this includes some of the big landmarks, such as the Science Centre in Vancouver, the Esplanade Rail Bridge in Winnipeg, as well as Nathan Phillips Square in Toronto. Other sites like the Calgary Tower, the Edmonton Bridge, lighting up purple. We have several city halls as well across the country, including smaller towns like Moncton, which are lighting, again, their buildings purple. As well, there are a number of free webinars across the country. In particular, I've noticed BC Lung Association is doing another webinar at the end of this month, as well as several others that are released or plan to be released this month. So keep an eye out for those as well. As well, I wanted to highlight, it's important to recognize CARST. This is the Canadian Association for Radon Scientists and Technologists, which focuses a lot of effort on education, training, research, community initiatives like the ones we've talked about, for which I sit on the board of directors for, and we work together to support that community. CNRPP as well, and this is an organization which monitors, regulates, and supports radon professionals across the country, for which we have, or Pynchon has, approximately about 25 registered professionals. So speaking of which, I am pleased to introduce to you our Pynchon regional practice leaders. These are dedicated team leaders and radon champions in their respective regions. They manage their own measurement and mitigation staff. They conduct testing, implement mitigation strategies, and collaborate with builders and developers on new construction projects. So starting from the east, and we'll go west, I've asked each one of these people here to introduce themselves and say hello.
Hello, I'm Shauna McIntyre, and I'm an operations manager in the Dartmouth, Nova Scotia office. I have been with Pynchon for a little over 20 years now, and I started studying in radon back in 2007, so going on 18 years, back when Health Canada first reduced the radon guideline from 800 to 200 becquerels. So I'm doing it, I just did the math, and that's a long time. So I've enjoyed it. Happy to say that we've grown our radon team here in Atlantic, slowly but surely. And we recently just had 2 new professionals become senior certified in our Newfoundland office. So yeah, we look after all of Atlantic here and hope to help people reduce their risk to radon exposure.
Hi, bonjour tout le monde. My name is Annick Bérubé. I'm from a sister company of Pynchon in Quebec. It's le groupe Gesphare Poirier Pynchon. So we work closely with Pynchon for every project. So in Gesphare, I'm an industrial hygienist. I've been with the company in the past 15 years. And I've been a radon measurement professional since 2011. So yeah, and well, my first projects were that the whole province had to test for all the schools in Quebec. So that was a big one. And since then, I've been working on every type of buildings. And we also have mitigation professionals as well who are certified here in Quebec. So, well, I'm pleased to be working with your radon projects.
Well, thank you, Nick. You've met me. I'm based out of the GTA in Ontario. Will Motriok is a project engineer out of Winnipeg, Manitoba. So unfortunately, he had an emergency today and wasn't able to attend the call. But he has similarly been in the industry for over 10 years now, working with me on a number of new construction, mitigation, and measurement portfolios for that time. So. And then next we have Nadine.
Good morning. My name is Nadine Brossart. I'm in the Regina office in Saskatchewan. I've been with Pynchon roughly 12 years now and a measurement professional with Radon for, I believe, 6 years. Currently, I'm the only one in Saskatchewan with some radon training, but we're hoping to grow our staff in this area.
Hi, I'm Ken Ma. I'm the IEQ operations manager for Alberta. I've been with Pynchon for 18 years and been doing radon for over a decade now. I'm a measurement and mitigation professional, and I do a lot of the new construction work here in Alberta for any new builds. We cover Alberta and Northwest Territories, so I would be your contact if you have any kind of radon concerns in Alberta or Northwest Territories. Thank you.
Wonderful. And you've met Heather, and she's out of our BC Richmond office. So thank you everyone for introducing yourselves. We encourage all of you on the call, if you haven't met your local Pynchon radon professional, please reach out to them. So today we have a rather full agenda, for which I hope we have enough time, but we shall start with the fundamentals of what is radon. Then we'll take a look at some of the most recent testing data available, legislation, guidelines around radon, as well as Pynchon's role and services that we offer.
Great. Well, I'm going to kick us off. I'm assuming everyone in this presentation, you've at least heard of the word radon, but maybe you don't know what it is, what the health effects are. That's what we're going to go over today. So radon is a naturally occurring radioactive gas. It forms when uranium in the soil, rock, and groundwater break down over time. So one of the challenges with radon is that you can't detect it with any of your senses. It's colorless, it's odorless, it's tasteless. So that means there isn't a visual or physical presence that tells us whether radon is high in a building. And because of that, the only reliable way to know what the radon levels are is to test your building. And on top of that, every building can be different. Even two buildings side by side can have completely different radon levels. So testing is always the first step. It's in all air we breathe, it's in our outdoor air outside, and it's in our indoor air inside. But when it becomes a problem is when the levels escalate, when they elevate to really high levels and they're trapped inside. And I'll talk a little bit about more why that's a concern on the next slide. Now, the reason we take radon seriously is the impact it has on our health. About 16% of all lung cancer deaths are linked to radon exposure. So if you've heard of people that have been diagnosed with lung cancer and maybe they've never smoked a day in their life, radon is a very likely cause of that. For people that don't smoke, radon's actually the leading cause of lung cancer. In Canada alone, there's roughly 3,200 lung cancer deaths every year that are attributed to radon. So that works out to about 9 deaths every single day. So when we're talking about radon testing and mitigation, it's not just a building science issue, it's a public health issue and a preventative care issue. And this chart on the screen really helps put radon into perspective. Radon-related lung cancer has more deaths each year than car accidents, carbon monoxide poisoning, and house fires combined. So that's a good way to put it in perspective with how serious this is. We tend to be really aware of those other risks I mentioned. We have other smoke alarms, we have carbon monoxide detectors, we have seat belts, we have traffic campaigns, but radon is largely invisible to public awareness, even though it has a much greater impact. And that's why testing matters. It's preventable once we know it's there. Here's a little bit of the science nerdy side I like to talk about. This is what actually causes the health risk. So when radon gas breaks down, it forms what we call radon decay products, or RDPs. These are really tiny particles that attach to dust and air particles that we breathe in. So when we inhale them, they stick to the lining in our lungs. And over time, those particles, they continue to break down and they release alpha radiation. And that alpha radiation damages the DNA in our lungs, which can lead to mutations. And that's what actually increases the risk of lung cancer. So it's not really the gas itself, it's the issue, it's these particles and then the ongoing radiation that happens inside the lungs. So now that I've convinced you that you have to test for radon, how do we measure radon? So when we talk about radon levels, in Canada, we measure them in becquerels per cubic meter, which we write as BQ per meters cubed. And that's just a way of saying how many radioactive breakdown events are happening in a cubic meter of air every second. So the higher the becquerels per cubic meter in your indoor air, the more radioactive particles you're breathing in, and the higher your risk of lung cancer becomes over time. And that's why measuring that level is so important. It tells us whether action is needed. So my next slide here, this is called a cloud chamber. And I mentioned that there's no sight, there's no scent, there's no anything to see radon, but this is kind of a helpful way for us to actually see radiation in action. So normally alpha and beta particles are invisible and you can't see radiation with the naked eye, but in this cloud chamber, the air is cooled and it's saturated with an alcohol vapor. And when the radioactive particles pass through, it leaves a visible trail, almost like a tiny jet stream. I'm going to show you in this video coming up. Let me hit the play button. Okay, so if you watch the screen, you should see these short, thick tracks. Those are the alpha particles, and the long, thin tracks are the beta particles. So this is a great visual of what's happening in the air and actually in our lungs when radon decay products release radiation. So we don't see it, we don't smell it, we don't feel it, but it's there and it's active. So now we'll get into how does radon actually get into buildings, and this visual is a good indicator. So the ground underneath a building is usually a higher pressure than the air inside. So the building itself tends to be under slightly negative pressure, especially in colder weather or when we're running exhaust fans, dryers, ventilation systems. And because air moves from high pressure to low pressure, the soil underneath the slab is essentially being drawn into the building through any cracks, any joints, any gaps around plumbing penetrations, some pits, any tiny openings you can't even see. So in the field, we demonstrate it with a smoke pencil, which is what you see on the right-hand side. And we can place the smoke pencil near a crack or a floor joint, and the smoke is pulled downward, showing that the interior is actively drawing air from the soil. So radon doesn't leak in a building. The building's actually pulling it in. You can kind of think of it like a vacuum. And once we understand that pressure difference, we can design a mitigation system that reverses it to keep radon out. And that's actually what we're seeing in this visual. So here we're looking at the opposite pressure scenario. This is what we aim to achieve with a radon mitigation system. So instead of the building being under negative pressure and drawing the soil gases in like a vacuum, we create a slight positive pressure in the building relative to the ground. And with a system running, you can see the smoke pencil here. This is when we've turned on a radon mitigation system, and the smoke is no longer being pulled downward. Instead, that airflow direction is reversed. The air moves out or it doesn't move at all, and it tells us the building is no longer pulling in any soil gas, including radon. So we're not cleaning radon indoors, we're preventing it from entering in the first place by changing the pressure dynamics. So where does it enter in buildings? I named a few places previously, but radon enters buildings from the ground beneath the foundation of the building. It's formed naturally in the bedrock soil and it moves upward into the buildings. It can enter anywhere because it's a gas, so really any type of opening. That could be cracks in the slab, that could be any gaps in plumbing, utility penetrations. I mentioned sump pits and floor drains previously, crawl spaces, and even pores in concrete itself. Concrete is not airtight. Another fun fact you might know, if a building uses well water, radon can dissolve into that water and be released into the air when you shower or run your taps. And that's what this diagram is showing here. Really, the main takeaway of this is radon comes in from below the building and enters wherever there's a pathway and a pressure difference pulling it inside. Every building has some openings, even if you don't see any cracks in your foundation, radon can get into your building. Two homes right next door to each other can have completely different radon levels. So knowing where it can get in is really a key factor to knowing how much radon is in your building. Here's another great visual to show of common places where radon does enter a building. And a lot of these are just regular building construction, so you wouldn't notice or even think that this could be a major entry point. So some places I haven't talked about in the previous slides, the cold joint is something to think about. The block foundation walls, they can act like a chimney for soil gas as well, and even hairline fractures that are too small to see. Key point is it doesn't take a large opening for radon to enter. If there is any pathway and that pressure is there, it will pull radon in and act sort of like a vacuum. Every building has potential for radon to enter. Even if the foundation looks tight, even if it's a new building or recently built, every building has some sort of opening. Which brings me to my next point. A common question that we receive is, my building doesn't have a crawl space, or my building doesn't have a basement, so I must not have a radon problem. And the truth is that radon can enter any type of building. It doesn't matter if it's a basement, a slab on grade, or a crawl space. What matters is the connection to the ground. There's only one type of building I would say, yeah, you probably don't need to test it, and it's a tree house. If your building is on stilts or has no ground contact, that's probably the only type of building you don't need to test for radon. Now, in a basement, you have the largest amount of foundation surface in contact with the soil, so technically there's more pathways for the soil gas to enter. In slab on grade, the slab is directly sitting on the soil, so radon can move through any of those cracks or joints or plumbing penetrations. And then finally, with crawl spaces, that ground is exposed, or if there's a membrane that's not sealed properly, radon can easily enter and be drawn into the occupied spaces above. So radon really isn't just a basement problem. Any building that touches the ground has potential for elevated radon. And that's why testing of all building types and all building ages is all recommended, not just buildings with basements. So in this slide, we're talking about how radon is distributed in a building, and there are several influencing factors for this. So the first is geological conditions. How much uranium is in the soil and the bedrock beneath the building? That influences the radon concentration. The building envelope as well. How tight is that building, or how leaky is that structure, and how many pathways are there for the soil gas to get in? Ventilation systems play a big role. How is the air moved? How is it exhausted? How is it recirculated? And even occupancy patterns. How are the buildings being used day to day? It's really important to be clear that this visual does not mean that radon only stays in basements. In some buildings, especially residential homes, air handling systems can easily distribute radon throughout the entire building. Even if the furnace or HRV is drawing air from the basement and circulating it, radon, again, is not just a basement issue. It's a whole building issue. And what we're seeing in this visual is the highest radon levels in this building are in the basement because it's closest to the ground in this case, and it's being slightly diluted as you move up the building and fresh air is being introduced. And it's highest at that lowest level because it's closest to the source. Radon is coming in through the soil. And as you can see here, it does move throughout the building depending on how the space is ventilated. So that's why testing is done in occupied areas, not just basements. It's not just one sample we put in a building. Health Canada's action level is 200 becquerels in this case. So even the occupied main floor, if no one was in the basement, would have elevated radon levels. So it's important to understand what the concentrations are in the air that people are actually breathing. That's why test location is really important. And I mentioned how radon varies between homes or buildings right beside each other. They can actually vary within the same building as well. Even rooms that are side by side can have completely different concentrations depending on the slab conditions. And this is a study that Pynchon did. I believe it was a school actually, which shows a very revealing radon variability in this building. So in this case, the red rooms had elevated radon and the white rooms did not have elevated radon. It's very important to test all of the occupied areas on the main floor for this reason. If we decided only to do a couple of test locations, we could have easily missed a problem. So this is a really great demonstration that's actually quite common of how radon varies between buildings. And that's for a lot of different reasons: airflow, pressure differences, paths of least resistance. We can't rely on a single detector for such large and complex buildings. We have to test all of the areas where people are actually spending time. So testing strategy is very important here. So we'll get into some of the factors influencing radon in buildings, and that's how much radon actually ends up inside of a building. So we touched on the geology underneath. Remember, radon comes from uranium and soil. So how much is actually in that soil directly below the building? Again, how tight and leaky is that building envelope? The ventilation system, how is it being recirculated in the building? How is the air moving? And also how the building is used. Are doors being opened frequently? Are exhaust fans on? What are the occupancy levels like? Is this a building that people work in, but now most people are working from home and ventilation conditions have changed? It's really important that these factors vary from one building to the next, even if they're on the same street, which is why radon can be really different in buildings. But the good news is here that all buildings can be fixed, no matter the age, no matter the foundation type, no matter how high radon is when you do your first test. There are effective mitigation strategies that reduce the levels very quickly and keep them low long term. We're not trying to set off an alarm here, but we are trying to set off awareness and action. So once you know your levels, we can do something about it. I'll pass it over to Alex for the next section.
Great. Thanks, Heather. Well, in 2014, Health Canada released a cross-Canada study. They tested approximately 14,000 homes and identified that about 7% of those were elevated. That's 1 in 13 homes. This study largely accelerated the conversation that we're still having today about radon gas and has driven a lot of education and awareness as a result. In October of last year, a new study was released where Health Canada worked in conjunction with Evict Radon, the University of Calgary, Carix Canada, and several lung associations and more. And they tested a significant amount of more homes and identified that the typical Canadian household has an average radon concentration of about 85 becquerels. That's approximately 18% of homes, which is about 1 in 5 that are above Health Canada's action level, or the recommended action, or the recommended amount in Canada. The study also demonstrates that detached homes have a higher risk compared to its semi-detached or row-style homes. Study also identified that more rural locations, such as small towns and villages, hamlets, have a higher risk than those larger towns and cities. And finally, there were some data that showed that newer homes as well have just as higher risk of radon concentrations than the older homes as well. And that although our homes are better insulated and better built than they were decades ago, because of that tight building envelope, it concentrates gases very well. On this slide is a map of the national results by province. So again, on average, we're showing here that 1 in 5 homes are above the Health Canada action limit. If we look at it by province, we see that BC is just below 16%. Whereas if we work our way east, it increases significantly to just over 25%. So that's 1 in 4 homes in the Atlantic regions test above the Health Canada's action limit. So who governs safety? Well, radon regulations in Canada is a shared responsibility between federal, provincial, and territorial governments. The federal government, through Health Canada, sets national guidelines and supports the provinces with action guides and technical standards, such as these two on the screen. We have a residential guideline as well as a public building guideline. It's these such guidelines that establish the action limit of 200 in Canada. That is a radon concentration not to exceed 200 becquerels per meter cubed. Now, 200, we throw around these numbers of 200 and 100 and 300, but what does that mean? How do we visualize that? And so Heather explained that 1 becquerel is a disintegration per second. And the cubic meters is the volume of air by which that represents. So if we can imagine 200 disintegrations within a volume of 1 meter cubed, if we can imagine, for instance, your oven at home is something that we can all visualize, and it represents just under 1 cubic meter of volume or air within that space. And if we imagine that there are 200 disintegrations per second within that space in your oven, that's what's happening in the air around us in a building that is sitting at 200 becquerels. So it's quite the visualization. It is the responsibility of these provinces and the territories to implement building codes. Okay, yeah, so thank you, Heather. So the federal government does provide guidelines, whereas it's the responsibility of the provinces to implement building codes, workplace safety laws, as well as tenancy regulations that might include radon provisions. The Health Canada documents provide guidelines for testing. They include the quantity of detectors that are needed for a space, where and when to test, and for how long to test. To answer the question in the chat, are there different times of day or year to test? Well, these guidelines provide answers for that, in that the best times to test, or the recommended times to test, is during the heating season, during the cold months of the year. And it is the recommendation to test for a minimum of 91 days, or 3 months, to get an average radon concentration over a period of time. As radon concentration can fluctuate quite dramatically, that average gives us a baseline for further steps. These guidelines go in so far as to recommend that a CNRPP professional be engaged in deploying and implementing radon tests. Health Canada recommends that within 2 years, when indoor radon concentrations they recommend mitigation within 2 years when radon concentrations exceed 200, and they recommend mitigation within 1 year when it exceeds 600. Again, to visualize 600 disintegrations per second within your oven. It is quite significant. It's important to note that for federal buildings and federal regulated employees, it falls under the Canada Labor Code, where that threshold is currently 800 becquerels per meter cubed. Although that is expected to be harmonized with Health Canada this fall, we are waiting for that update. So in Canada, workplace safety is largely a provincial matter. It's important to note that every province has their own Occupational Health and Safety Act, which is strictly enforced by the Ministry of Labor or the like in those provinces. Within the Occupational Health and Safety Act is what is generally referred to as the General Duty Clause. So on the screen, I've put the language specifically for the New Brunswick General Duty Clause, which is every employer shall take the reasonable precaution to ensure health and safety of its workers. Some provinces will include the language to protect workers from hazards. So in New Brunswick, under the regulations or general regulations for indoor air quality, this includes airborne contaminants. In Ontario, for example, these hazards and this language particularly includes radon gas and specifically includes that language, radon gas. So this is particularly important, as Heather said, it is the second leading cause of lung cancer after smoking. But further to that, WHO and CAREC, so WHO, the World Health Organization, as well as CAREC, the Carcinogen Exposure Canada, identify radon gas as a priority level carcinogen. That is a carcinogen, again, is a cancer-inducing agent. So there is direct evidence that shows that prolonged exposure to radon gas can lead to lung cancer. In the same level, and is in the same category as arsenic, asbestos, and silica dust. So in summary, it is the employer's responsibility to provide a safe workplace. Similarly, it is a landlord's responsibility to provide a safe building. When we talk about radon in new construction, British Columbia, Alberta, and Ontario have updated their building codes to require now radon rough-in systems, or RRNCs, in new homes and small buildings. These systems typically include passive stacks or venting infrastructure to facilitate future mitigation. Also note that most provinces in Canada do follow the National Building Code of 2020, which means they also have the same requirements for RRNC systems in all new residential. A new National Building Code is expected to be released in late 2025, so right about now, before the end of the year, mandating passive stacks nationwide, with provinces expected to harmonize within the next 18 months. So we'll talk a little bit more about new construction later on in the presentation.
Thanks, Alex. Back to me here. So now that we've covered some of the fundamentals, I just wanted to briefly highlight how Pynchon can support clients with radon. So we provide radon measurement testing, ranging from individual buildings to large full portfolio programs. That includes planning, deployment, tracking, reporting, and program management. So organizations don't have to do that internally. We also support BOMA, WELL, LEED certification requirements. So radon testing is a good way to get your points for some of these certifications as well. We work with property owners, building managers, tenants, and of course we support homeowners as well who want reliable accredited testing with clear guidance and steps. And on the mitigation side, we do provide full radon reduction services, and that's from diagnosis and design all the way through installation and verification testing. Alex also touched on new construction. We offer design and engineering solutions there as well that help incorporate radon protection right from the start. So that's really the most cost-effective approach. So whether it's testing, mitigation, or even long-term portfolio strategy, we can help whatever stage you're at with your radon needs. We'll get a little bit more into the radon measurement side now. When we talk about radon testing, the gold standard is long-term testing. That's a minimum of 91 days, ideally during the heating season. And why is that? Is because the radon levels naturally fluctuate day to day, season to season, depending on the weather, the stack effect, and how the building's being used. So we want a true average exposure to base our decisions on. Generally, alpha track detectors are what's most commonly used for this type of measurement. You'll see in the photo that small black square, that's the test device we're installing in buildings. It's passive, it's low profile, and it stays in place recording measurement levels over the time. It's very reliable, lab validated, and it represents actual breathing exposure, not just a moment of time. The key message is short-term tests tell us where we might need to look more closely, but long-term tests are telling us what we actually need to do. So if we take a long-term test over the heating season and levels are elevated, that indicates that mitigation is recommended. You may have also heard about short-term tests before. There are a couple of options for this, typically anywhere from 7 days up to 30. Really, these tests are useful for a few specific situations where you might need to make decisions quickly. So we use it for diagnostic testing, so we can understand how radon is moving through a building. We might do that after we know there's already an elevated radon problem. We also might use it to screen a space before committing to a long-term test. There's a couple of different tests you can use. You see that small black box again in the upper right-hand side. That's another alpha track detector. It's called a Rapidos. And the bottom left, the red, and the one in the middle, those are called CRMs, continuous radon monitors. Those are like computers kind of that we install in your building, and those collect the radon levels every minute or every hour, whatever we set the device to. The key point is that short-term tests don't replace long-term testing by any means, but they can be useful for decision making, for screening, and for diagnostics when timing matters. This graph is a good illustration of why we want to do the long term and why it matters. Radon levels naturally rise and fall, and sometimes quite dramatically, depending on the weather, ventilation, stack effect, all the things I mentioned before. And you can see in this visual here that there are a lot of peaks and valleys. And if we were only to do a short-term test during one of those peaks, it could trigger a false alarm. And if we tested only during a valley, it might give a false sense of security. So what we're really interested in is that average exposure over time, because that's what relates to the health risk. So while short-term testing does play a role, long-term testing is what gives us the true picture to ensure we're making the right decisions here. Our radon mitigation services, so once you've done your test, your long-term test, we compare it to Health Canada's action guidelines, which is 200 becquerels per cubic meter. So if the long-term average is below 200 becquerels per cubic meter, no mitigation is required, although we might still monitor things again in the future. If it's between 200 and 600 becquerels per cubic meter, Health Canada recommends mitigation within 2 years. And if it's above 600 becquerels, we recommend mitigating 1 year or sooner. And why is that? The higher radon levels, the sooner we should mitigate. And it's also worth noting that Health Canada recommends considering mitigation even below 200 becquerels per cubic meter if levels are close to the guideline, especially in places with vulnerable populations, so homes, daycares, long-term care, those would all be considerations. So if radon is above the action limit, the building must be mitigated. It's not optional. This is a health protection measure, and mitigation is highly effective. I'll talk about it in the next coming slides, but when it's designed and installed properly, it's an extremely reliable system that can reduce levels very quickly. So this image shows a home or a building before and after radon mitigation. So on the left-hand side, that's the before mitigation, where the building is at a lower pressure than the soil and radon is acting like a vacuum and being pulled up into the building through all of those entry points we spoke about previously. On the right, this is after mitigation. So we've installed, in this case, a sub-slab depressurization system. And what happens is it creates a slight vacuum beneath the slab. So instead of radon being drawn into the building, it's captured and vented outside. So the concept here that some people get confused about it is we're not cleaning the air to get rid of radon. We're preventing it from entering in the first place by changing those pressure dynamics. I showed you these smoke pencil pictures previously. So that bottom picture is after a mitigation system has been installed and turned on. A very effective and reliable approach. So this is what a mitigation system, a sub-slab depressurization system, typically looks like in practice. So we install a pipe that goes down through the floor slab into the gravel or soil layer below, and a radon fan is installed in line with that pipe. It's usually located in the attic or sometimes in the basement. That changes depending on the weather of the location we're installing it in, but it's never exhausted inside the occupied space. The fan that we install, it creates a slight vacuum beneath the slab, and that's what's preventing radon from entering the building. So instead, the radon gas is drawn into that pipe and it's vented safely outdoors, whether out the sidewall or the roof in this case. The pipe, it's sealed tightly, and all the floor and wall penetrations, we want to prevent air leakage, so we're not venting it into the occupied space. This system runs continuously, so 24/7, it is always on, but don't worry, it uses very little energy. It's similar, it's very comparable to running a bathroom exhaust fan. And when it's installed properly, it reduces radon levels very quickly, which also shows some demonstrations of in a couple of slides. So what it actually looks like, here's what a sub-slab depressurization system looks like in real life. And this is really a great standard of what it would look like. So you can see the PVC plumbing, the PVC piping rather, it's running vertically. The radon fan is that small circle oval in the middle. It does require electricity to plug in the fan, but these systems are never usually installed in occupied areas. In this example, we've placed it in a mechanical room, which is quite handy, but it's very small. And also I should mention a common question we get is how noisy is this, having a fan running 24/7 in our building? It's actually quite quiet, even though it runs continuously. And the levels do drop quite quickly. So I want to show you in the next slide really how effective these systems are. So as you can see here, this is what mitigation looks like in real time. So in this case, the building started with levels close to 2,500 becquerels per cubic meter. And if you're wondering if that's a really high number, it is high. It's 10 times higher than Health Canada's action guideline, but it's also quite common. We see levels like this all the time. And this vertical line shows when the system was turned on. When that fan was turned on, you can see how quickly radon levels dropped. Within hours, it dramatically, I think it's over the course of a full day, it levels out to where you'll see the long-term measures. But I think we got levels probably close to 20 becquerels per cubic meter, which is pretty close to outdoor levels. So in buildings with very high radon concentrations, this is just as effective of a system. effective, consistent, pretty cost effective as well, and very, very measurable and reliable. So one hit home point I want to take here is that all buildings can be fixed, whether it's a sub-slab system. There are similar systems we would install called a submembrane if there was a crawl space. And there's also some solutions we can offer with HVAC modification, HRV systems. In that case, it might be more of a dilution approach, and we can assess if that's practical for your building as well. But the message is we shouldn't be afraid to test, because absolutely every building can be fixed if there is a problem. So we can reduce it reliably and permanently. And I'll throw it back to Alex, who's going to talk about a little bit more on mitigation.
I was on mute there. So about 90% of the buildings we fix utilize these methods Heather described of depressurizing the building. The other 10% explore a ventilation approach where we seek to dilute the radon gas in the air by providing more fresh air. Those situations are unique, and they do require a unique building and unique application, but we do this as well. It's particularly it's Pynchon's experience and expertise in these areas that really provide value, is what I'm trying to say. When we design these radon mitigation systems, we're often working very closely with other groups within our team. We work very closely with our building science division when we're considering foundations of a building or building envelope and how we impact that by exhausting or drawing on soil gases. We work with our mechanical engineers to review the HVAC systems to identify opportunities for ventilations or limitations when they apply. We have a hazardous building department, a hazardous building materials department, as well as a mold department when we come in contact with those hazards, such as asbestos or lead or silica. We also work closely with our soil contamination team when we identify the additional presence of methane or VOCs within the soil. And finally, we work with occupational health and safety here as well. So when we identify a confined space, to provide safe working procedures for entering and working in those spaces. So finally, we've got about 10 minutes left, and I do want to leave some time for questions. So we'll sort of quickly go through the new construction a little bit. We know that radon concentrations can vary significantly from building to building, and Heather's clearly raised that for us here. But when it comes to new construction, there's no way to test the soil and predict what those radon concentrations are within a building. So what we do here with new construction is we incorporate these, what we call rough-in systems, into the design and installation of or during construction. The steps here are taken to minimize radon entry and to install control options to facilitate post-construction radon removal, should it be necessary. It's important to state that these systems are not mitigation systems. They're more like design strategies to make it easier and much more cost-effective if radon is found later. So the key components to these systems are simple. A soil gas layer, a soil gas barrier to prevent or to impact to prevent the radon gas from ingressing into the building. A gas permeable layer below that membrane to facilitate airflow of those gases below the foundation, as well as a collection system. So this often includes a series of pipes to draw on or to facilitate the drawing on that soil gas if required. The costs associated with these RR&Cs during construction typically cost $200 to $300 in material cost alone for new homes. whereas the cost to install a system after construction can average anywhere between $4,000 to $6,000, depending on where you are in Canada. Note that in Ontario and Alberta, rough-in stubs are required for all residential and small buildings. Also note that most provinces, although I highlight Ontario and Alberta, most provinces do require these rough-ins as well. So if you're buying a new home these days, chances are you will find a rough-in system somewhere in your basement. On the screen is just a few examples of what these rough-in systems can look like for smaller buildings. Whereas for homes, we often don't see these pipe loops or cages underneath the house. Notably, and most notably, is new construction in British Columbia, which is a trailblazer at the moment, has gone so far as to require passive radon mitigation systems province-wide. What this means is that all new construction and small buildings will have rough-in pipes extending from below the slab to above the roof to naturally or passively allow that soil gas to escape from underneath the building to reduce that risk of radon gas entering or concentrating within your building. So with that, in summary, we'd like to conclude the presentation and highlight the importance of testing, understanding, and mitigate or take action if your radon concentrations are high. Radon is invisible, but the solution is not, and all buildings can be fixed. So with that, thank you, and we will open it up to questions. I believe you've okay.
We have a question from
We
Neil.
Neil, you should be able to unmute. Ask your question.
You can also type in the chat if anyone has any questions. So Neil, if you want to type in the chat or unmute, I'll get to some questions that we have.
Hi guys, I think I got
Go
it.
ahead, Neil. Great, thanks.
A question. So I got a house that was built in 2015, and I did test for radon in my basement. It was even with the 25 or 30 point or whatever. There's I forget what you call it, but I was underneath the 200. But is there like a discretionary of like 25 or 30 that has to be like an error rate or something like that? I was still under the 200. My question is the stub is put in a horrible spot. At what point can a person cap it or get rid of it if I was under the 200, should it be tested again in 2 years or 3 years, or like at what point can it be put to bed?
Okay, so there's a lot of questions there. First and foremost, these stubs that we see in new constructions, we are seeing a lot of them in the wrong locations or in locations that are just simply unusable. Unfortunately, this is something that the industry is working on. But to your next question, the system should be capped already, and there should be a sealed cover atop of it, so it should not be contributing to the radon concentrations within your building. I would urge you to keep that stub there and to not open that or tamper with it unless you need to. With respects to retesting, so Health Canada does recommend that you retest a building every 5 years. Understanding that the building does age, the building envelopes do wear and tear, including the foundation, and occupancy over time as well changes. So recommendations of retesting every 5 years.
Awesome, thank you.
Neil, we do have a bunch of questions in the chat, so we'll we'll get to as many as we can. However, if we don't catch your question by the end of this session, we'll email you guys directly and we can reach out. So I'm just going to start off with the latest question we see from Andrea. Does Pynchon offer designs on depressurization systems for new home builds? If so, are they designs worded or CAD design? Alex, I'll let you answer that for us.
Sorry, Heather, I didn't see that in the chat there.
Yeah,
What was
it's
the
the
question
newest
again?
one it's the newest one in the chat. So do we offer design for depressurization systems in new home builds? We do, Andrea. Yes, we do. And if so, are the designs worded? I think what you mean is it a report? Does it also include a CAD drawing?
Okay, so it depends on who we're working with. So if we're working with a builder or a developer, we can provide the information within design specifications, which is often what they're looking for, in addition to CAD drawings. So we will incorporate our drawings or our designs within the architectural drawings. If we're working with a homeowner or another client, then we can design or we can modify that to be I understand that specifications are often not the easiest thing to read, so we can design that to a more report template as well. But yes, we do provide drawings for either or as well.
Thanks for the question, Andrea. We also have a question from Brad, the approximate cost for testing a regular residential home.
Okay, so great question. For testing a residential home, I would encourage you to purchase a radon detector and to do the tests yourselves. Pynchon does offer radon detectors on our website. They are, I believe, they're about $50 per detector. So the costs are quite low. This is a one-time use detector. You open the package, you put it in the lowest occupied level of your home. And with that package comes instructions for how to deploy, as well as how to return it back to us so that we can have it examined, and we will forward you the results afterwards.
So our
great
website
question.
is Pynchon.com, Pinchin.com, and there's a radon homeowner section that will give you more information, and you can purchase if you're interested. Okay, let's see, we've got a couple more. One last question we have. Can RDPs be removed or treated once in our lungs? It's a great question.
That is a great question. So now again, I'm not a doctor, but from the information that I've read and we've been presented on from a number of doctors and professionals in the industry, our bodies have a natural way of cleaning themselves. And I understand that these radon decay products, often lead or some of those other daughters, radon decay daughters, will get processed out of the body. Some of them do stay within the body and accumulate in particular areas, such as bones, for instance, or nails, but some of it does get flushed out over time. Okay.
Those are all the questions we have in the chat for now. So I think we'll close up here. Thank you so much, everyone, for joining. You will receive a copy of this presentation after this wraps up. We'll also have our contact info. So if you need to reach out to any of your local experts, so Nick, Nadine, Alex, myself, Will, Ken, we can put you in touch with our local experts as well. Thank you so much for joining us, and happy Radon Awareness Month.
Thank you. Bye.
Thanks, everyone.